So we are going to be proving that a quadrilateral is a parallelogram, and you can find this in 5.6 in your books if you want to follow along. Our objectives, we actually only have one, and that is to prove that a quadrilateral is a parallelogram. I'm going to get tongue-tied a lot during this one, so bear with me. But the reason we're doing this is because in the next section, you're going to be proving special types of parallelograms, squares, rectangles, rhombuses, and if you're not given that it's a parallelogram, you need to prove that it's a parallelogram first before you can move on and prove the special types, with a few exceptions, but we'll get into that later. Okay, now any one of the following methods can be used to prove that a quadrilateral is a parallelogram. So if both pairs, now this is important because it's got to be both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So if you have a figure such as this, and you can show that that's parallel to that, and that's parallel to that, you have a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So even though it doesn't exactly look right here, that's congruent to that, and that's congruent to that, you have a parallelogram. If one, okay, number two, that was also both. For three, that's just one. If one pair of opposite sides of a quadrilateral are both parallel and congruent, the quadrilateral is a parallelogram. So think about it. I've got two lines, okay, and they are parallel, and they're also congruent. That means they're the same length and they never intersect. So no matter how you arrange them, you're always going to have these two other segments that when you join them are also going to be parallel and congruent. So just something for you to think about. And if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Because again, no matter how you arrange it, if it's a parallelogram, the diagonals would bisect each other. Okay, so that means that both of them are bisected. Okay? And finally, if both pairs of opposite angles of a parallelogram are congruent, quadrilateral is a parallelogram. So if that's congruent to that, and that's congruent to that, it's a parallelogram. So those are 5 methods that you can use to prove that a quadrilateral is a parallelogram. And let's actually put it into a proof and see what we can come up with. So we are given that ACDF is a parallelogram. Okay, so that's ACDF. And that angle AFB is congruent to angle ECD. And we need to prove that FBCE, so this smaller one inside it, is also a parallelogram. Like my lightsaber proof T there. I was going to try and put in sound effects, but thought that might be a little bit too geeky. So, we start with what we're given. That ACDF is a parallelogram and AFB is congruent to ECD. AFB and ECD are congruent. That's given. Next, because it's a parallelogram, we know that opposite angles of a parallelogram are congruent. So I can say that that is congruent to that. And see where I'm going here? Because I'm going to need to do something with these triangles here. So now I've got 2 angles from each of them. Now I can say that AF is congruent to DC because opposite sides of a parallelogram are congruent. Now I can prove that AFB, triangle AFB, is congruent to triangle DCE by angle side angle, as I showed in 1, 3, and 2. Okay? Now how does that help me? Because remember what I need to do to prove a parallelogram. Well, one thing it does is I can say that FB is congruent to EC by CPCTC, and I can also say that AB is congruent to DE. Hopefully you're not wondering why I'm including those, but you might. And if you are, pay close attention, because I like this proof, and when I like a proof, I tend to throw them on quizzes. So, or they might be on the test. Just saying. All right, so, and that's by CPCTC. And then I can also say that segment AC is congruent to segment FD for the same reason as 3. Opposite sides of a parallelogram are congruent. Now maybe you're seeing why I needed this, and then I'm showing that. Because I can now say that BC is congruent to FE because of subtraction. So I had this big one, subtracted the small one, and it left me with something smaller. So remember, if you have something and it's not being divided evenly and you're making it smaller, it's going to be subtraction. And then you can say that FBCE is a parallelogram because if both pairs, so I've got one here and one here, and I then showed this, both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Okay, so that's how you would use that in a proof. And then you would have to, again, sometimes you'll get these algebraic problems. We need to prove that the quadrilateral is a parallelogram. So in other words, what we need to do is somehow show that because think about what we have here, we've got angles. So we'd have to show that this angle is congruent to this angle, and that this angle is congruent to this angle. So let's start with the inside here. We've got x to the 7th on one side. We have to figure out if x to the 5th times x squared equals that, because if this is a parallelogram, they'll be equal. Now hopefully you remember from algebra that if you have the same bases and you have exponents that you're multiplying, you add them together. Same number of bases as there are powers, you add. So 5 plus 2 equals 7. That checks out. So we can say that this is congruent to this, because this equals x to the 7th. Okay, now let's look. We've got two parallel lines here. That's what we're assuming at least. And if that's true, then this would have to be congruent to this. And you might be wondering how, but they're kind of alternate interior angles. Okay, because these are if these two are parallel, then these would be corresponding, and they would be alternate interior angles. So let's see if they check out. X squared minus 25, does that equal x minus 5 times x plus 5? Well, so we're not going to do anything with this. Well, you could factor it out if you wanted to, or you can see if using FOIL on this works. So first, x squared. Outer, plus 5x. Inner, minus 5x. Last, minus 25. Okay, this right here equals 0. They cancel out, so we get rid of that. Leaves you with x squared minus 25, which is exactly what that was. So these angles are congruent. And I could say by substitution that if this is supplementary to this and this is supplementary to this, and they're congruent, that means that this is congruent to this. And because of that, because opposite angles are not congruent, we can show it's a parallelogram. Okay? As far as whether or not something like that would be on your test or quiz, it's a possibility, but less likely than the proof. I'll let you know though, don't